So similar to the previous video, but this time we're going to make the comparison between limits and a quadratic approximation. So let's look at this example. Let's try and approximate cos of x. So we've done this before in the past. Whenever you have y equals cos of x, it will look something like this. We could use a linear approximation. A linear approximation near x equals 0 would give us this. It would not be a good approximation, but we could use a linear approximation. But a better approximation would be to use a quadratic approximation. So to create a quadratic approximation for x being for x being near x equals 0. So we're going to try and create the equation for this quadratic that will approximate it at x equals 0. Okay, so we would start out with our quadratic, and we've done this before. So if you can't follow this, then track back to one of the early videos. So we would start out with our quadratic. We would start out with our original graph. Differentiate this, differentiate this, differentiate this, differentiate this, and then set. Looking at this and looking at this, x equals 0. Put it into here. This thing will be 1. So when x equals 0, this thing here will be 0. This thing here will be 0, leaving you c equals 1. C equals 1. Now if you don't follow this, then track back to one of the early videos. Now look at this, look at this. At x equals 0, this thing here will be 0, the whole thing will be 0. And then at x equals 0, this thing here will be 0, so b will be 0. B will be 0. Now look at this. Put 0 into here. This thing here will be negative 1, and this thing here will be this. So we've got to set this to be equal to negative 1. So 2 blah blah a equals negative 1 over 2. So a equals this. So now looking at this, we've got a, b, and c. So that will then give us our quadratic. The point I'm trying to make here is that to approximate cos of x, we can approximate it to this. So that's our equation up here. This is our equation here, because we've got our a, b, and c. So we've got our quadratic equation here. Well, when near x equals 0, this thing here is approximately this. So when you take the limit as when you take the limit of cos of x as x tends to 0, well, the concept behind the limit, behind x going to 0, you're really taking x towards something along the line of 10 to the power of something really, really, really small. So you are definitely within this region. So whenever you're within this region, you can, if you encounter cos of x, you can actually approximate it to this. Rather than working with this, you can just work with this around this region. But then when you take the limit as x tends to 0, you are definitely within this region. You are definitely within this region. Because when you take x, well, when you take the limit as x tends to 0, you're really talking about a very, very small number. Well, this very, very small number is within this region here. So whenever you encounter cos of x, you can't just use this. So now let's look at our example here. Let's say we're trying to find the limit of this as x tends to 0, but instead of using L'Hopital's rule, we're going to use quadratic approximation. So quadratic approximation, when x is near x equals 0, then you can just say this thing here is equal to this thing here, because remember from up here we said that near x equals 0, cos of x is approximately this. So if you look at this, cos of x, well, we can just put this into here. That's this bit here. Okay, so now tidy this up. These two will cancel out. This gets multiplied to the bottom. That will then give you this, and then these two cancel out, giving you negative a half, giving you negative a half. Okay, and then so this is our approximation method. Now let's look at L'Hopital's method. So our approximation method gave us negative a half, Now let's use L'Hopital's rule. So looking at this here, we would put this into here. You can see that it's going to be 0 over 0. So we can apply L'Hopital's rule, differentiate this, and then it's going to be 0 over 0 again. So differentiate this, and then blah blah. The answer will be negative a half, which is consistent with our approximation. The important thing here is that when you take the limit as x tends to 0, you are really entering this realm here. You are really considering x being near x equals 0. The point is that these two, when you take the limit as x tends to 0, you can also use this method here, and this method should coincide with L'Hopital's rule, which it does in this case. Okay.